Hey, Mr. Richards here for our last 8th grade anchor problems this year. I'd like to just focus on one question. I believe it's problem 6 in your packets for Unit 7, Lesson 16. And it's a doozy of a problem, and so we'll go through this one together. Tennis and golf balls. Tennis balls are packaged into cylindrical cans to ship and sell. 3 tennis balls fit into one cylinder so that the height of the 3 balls is equal to the height of the cylinder. And the diameter of one ball is equal to the diameter of the cylinder. So let's focus on this tennis balls first in part A. The radius of one tennis ball is 1 3/10 inches. How much airspace is in the cylinder around the tennis balls? Let's figure out the volume of one tennis ball first. Volume is going to be equal to 4/3 times pi times our radius cubed. So volume is going to be 4/3 times pi. Our radius is 1 3/10, and that's going to be cubed. And so first step here, if I take 1 3/10 to the third power, that's going to be equal to that 2.197. And so we have 4/3 times pi times 2.197. Now, this 2.197 then times that 4/3. 4/3 times 2.197 is going to be 2.29 or 2.9293 if I can read there. So our volume is equal to 2.9293 pi. There are 3 of these tennis balls in there. So I do need to multiply this by 3 now. So that way I can get this thing now times 3 is going to equal, I've got to see if I can clear this stuff out first. 8.7879. 8.7879 pi cubic inches. I'm going to keep that pi for now. Okay, so that's the volume of the 3 balls. 3 tennis balls. Just so I have that labeled there, and so we know what we're dealing with, and we can come back to that. Now, if we're looking for the volume of the entire cylinder, we need to figure out some dimensions first, don't we? We know from here to here, that's the same thing as the diameter of one tennis ball. That's 2.6 inches. This piece is going to be another 2.6 inches. This piece is going to be another 2.6 inches. And so if I were to take 2.6 inches, 2 6/10 inches, times 3, that gets me 7 8/10 now for the height. The radius is still going to be the same radius as one of these balls, which is 1 3/10 inches. And so the volume of the cylinder is pi r squared times the height. So pi times 1.3 squared times our total height of 7 8/10. So pi times 1 3/10. 1 3/10 squared is equal to the 1 69/100 times 7 8/10. And so 1 69/100 times 7 8/10 is equal to 13 182 thousandths. So 13 182 thousandths pi cubic inches is the volume of the cylinder. So the cylinder can is right there. Now, how much airspace is in the cylinder around the balls? Well, if the entire volume of the cylinder can is 13 182 thousandths pi cubic inches, and the volume of the 3 balls is this 8 7,879 10,000ths pi cubic inches, all we need to do is for the air. Take the 13 and 182 thousandths pi, subtract the 8 and 7,879 pi, and we end up with 182 minus 8.7879 is going to be that much pi. So as exact answers we could be would be 4.3941 pi cubic inches. But if you take that number now and multiply that by 3.14, you get 13.7975. So this amount of air is about equal to 13.7975 cubic inches. That's how much air is there. Now, let's move on to the second part of these questions now. Golf balls are sometimes packaged into square prisms to ship and sell. 3 golf balls fit into one prism, similar to how tennis balls fit into the cylinder. What is the formula for the volume of the square prism? Give your answer in terms of d, the diameter of the ball. Well, this dimension here is going to be 1 diameter. Coming back is going to be 1 diameter. And then coming down, got 3 golf balls in there, so 3 diameters. Now, volume of a square prism is typically length times, that's a terrible W. I don't know what that even is. Length times width times height. And so volume is going to be equal to, in this case, our diameter times 3 of the diameters. Well, d times d times d is d to the third, and with that 3, it's just going to be 3d to the third. So that's part B. That's the volume of the square prism according to the diameter of the golf balls. Now the volume of the square prism is 192. What is the diameter of one golf ball? Well, 192 is the volume, equals 3 times d to the third. Divide by 3 now on both sides. And 192 divided by 3 is equal to 64. And so 64 equals d to the third. You take the cube root of both sides now. The cube root of 64 is the same thing as 64 to the 1/3 power. And it's going to be 4. That's nice. 4 is equal to the diameter. So 4, we're in centimeters, it looks like, equals the diameter of one of the balls. So that's our answer for C. By the way, our answer for A was over here. Now, how much airspace is around the square prism around the golf balls? Well, we need to find the volume of one of those golf balls first. And so the volume for one golf ball, once again, 4/3 times pi times the radius cubed. 4/3 times pi times the radius of 2. Diameter is 4, radius is 2 cubed. 4/3 times pi times 8. 2 to the third power is 8. And if we take 8 and multiply it by 4/3, we're going to get 10 2/3. So 10 2/3 pi is the volume of 1. If I multiply that by 3, I'll just go 10.6666666666 times the 3 is going to be equal to essentially 32. So I'm comfortable with saying that this is going to be 32 pi for these balls. Now, we knew the volume of the square prism was 192, so it would be probably helpful here to just take 32 and multiply it by 3.14. And when we do that, we get 100.48. And so this is really 148 hundredths of a centimeter, or a centimeter, 148 hundredths cubic centimeters. And so that's the volume of the three balls. The square prism was 192. So if you take 192 and subtract 148 hundredths, 192 minus 148 hundredths is 91 and 52 hundredths. So 91 and 52 hundredths cubic centimeters is the volume of that airspace. And so if you look at just this one question, really our last question of the year, and look at everything that we had to do in this one question, we had to find the volume of one sphere and multiply it by 3 to get the 3 tennis balls. We had to use that information about the diameter and radius of the sphere to build the height of the can and the radius of the can in order to find the volume of the can. Then we simply subtracted the volume of the can by the volume of the three balls to get the volume of the airspace. That was the first part. Then, knowing that volume is length times width times height for our rectangular or square prism here, the length and the width were both d's. 3d was our height because there were three balls. d times d times d was d to the third times the 3. So 3d to the third was the volume. Then, knowing that that volume must be equal to 192 from our problem here, we could divide by 3 and take the cube root to get the diameter of 4. Of course, if the diameter was 4, our radius was 2. Used this to find the volume of one golf ball. Multiply by 3, use the 3.14, and we have the volume of the three balls. So we have the volume of the entire square prism at 192, the volume of the tennis ball or golf balls at 148 hundredths, and you subtract to get a final answer. And that's it for this Unit 7, Lesson 16 anchor problems. If this is the last video you watch of the year, I wish you the best. I hope to see you in class on Wednesday. Best of luck in high school if I don't see you Wednesday. And bye, guys.